behalf of a large team at LCO. Advance. There we go. Okay. No, I'll stick with them. Okay, so we've seen variations of this diagram a few times, but this is sort of how we envisage the LCO projects fitting into the time domain ecosystem. Up in the top left, we have the existing surveys. So these are things like Gaia, Pan-STARRS for near-Earth objects, the Gravitational Wave Observatories, and obviously Rubin is the one that's sort of coming. All of these surveys produce both long-term data releases, which go to data archives, but they also produce alerts that go through various alert brokers and data sharing services. And the number of these alerts is going to be increasing considerably over the coming years. These then go on to science teams that have organized themselves to study objects of a particular type, which they're particularly interested in. And these science teams are deciding which one of these objects or which ones of these objects are the interesting ones. And they are sending those off to other observatories to get follow-up and characterization information. And then that data is also going into the archives. So it really becomes a question of how are you going to organize and keep track of all of this information on all of the targets that you're interested in. And so this is where the TOM Toolkit comes in. So the target and observation managers are systems for managing astrophysical projects for your particular science interest, whether it's supernovae, whether it's AGN, whether it's variable stars or asteroids. So it provides a searchable database which has information about all of the objects. It provides you with links to observation data analysis tools so you can request observations and analyze the data that comes back. It provides communication tools so your science team can communicate among themselves and decide on increasing the priority, decreasing the priority of a particular target, what it might be, and so on and so forth. And it has data visualization tools. And all of this is open source and customizable. And so this is an example of one of a TOM system. So this is SNEX2, the supernova exchange, which was built by the Global Supernova Project at LCO. So there's the basic information at the top, the name of the object, its redshift, position on the sky. There's the set of comments that says, this has been followed up. We think it's this type of object. We've got a visibility plot that shows where it's up at the various Las Cumbres sites. And then at the bottom, there's the existing photometry and spectroscopy data. This is another example. This is the black hole TOM, which is analyzing candidates from Gaia. Wukash has a talk later in this session, and he'll explain a lot more detail about his particular TOM. So the toolkit was first released in September 2019, and we held a community workshop to tell everyone about this new toolkit that's available. We had a version 2 a year later, and then in 2022 we were awarded an NSF grant to carry on the development over the next sort of 3 years. And the three main focus areas are the multi-messenger astronomy, engaging with Rubin Observatory, so that is support for alert brokers. Various of the broker talks previously have mentioned that they have TOM Toolkit plugins, and also including follow-up telescopes, and Brian will tell you more about that later. The third component is user support and engagement. So that particularly includes support for Rubin science collaborations if you want to build a TOM to organize your science. Recently, we've added data sharing through Hermes, which you heard a little bit about earlier, and I'll talk about more later. And we've also added TOM-to-TOM sharing. So, you may take a classification spectrum or something and it's not interesting to you, but you might want to give that to somebody else. And so they don't spend another hour of 8-meter time reclassifying it. So as an example, I'm going to talk a little bit about NEO-Exchange, which is our small body science focused TOM system that we have built at LCO. So NEO follow-up is coordinated across a range of facilities. We have candidates that come in. These are primarily Pan-STARRS and Catalina at the moment. These require additional follow-up to confirm that they're actually NEOs, and this is where NeoFixer, built by the Catalina Sky Survey, comes in to handle that. Once it's confirmed as a NEO, we pass it to characterization. So we want to do things like get photometry, light curves, colors. We want to take characterization spectra. The unique thing in the asteroid field is that we can do radar imaging of our targets because they're sometimes close enough to do that. Or we might want to take infrared imaging and spectra with facilities like JWST or ESO-X-Shooter. So NEO Exchange and all TOMs ingest targets from various sources. In our case, our broker, in inverted commas, is the Minor Planet Center, which coordinates all small body follow-up. We also ingest from Goldstone for the radar target lists, and NASA has its targets lists of things that they would like. We can also, users can basically put their own targets in. So we are running a key project to monitor comets, which is called Look. And so those can be added if a new comet is discovered. And the TOM also has spectrophotometric and flux standards for calibrating spectra. So we ingest all of this information about our targets. You can then schedule it to be observed at the LCO facilities. So you can either take a single snapshot or you can set up a repeated cadence and say, I want to look at this thing every 3 days plus or minus 6 hours. This is something we do for the Look project all the time. As the observations come in, we have a data reduction pipeline, which does an astrometric fit, 0-point calibration, source catalog production, and we actually ingest all of the entire contents of the source catalog into the database. And then we can go on and do a cross-match, and we can basically say, where was the object at this time? Is there a catalog source measured? And then you can use that to build light curves, as shown in the bottom, or these what we call guider movies. So this is just the asteroid. The telescope is tracking the asteroid across the sky. We have analysis tools for doing light curves. We can do period determination and phasing. We can check the orbital coverage of our targets and analyze reflectance spectra and compare them with analogs. And the other thing, I forget who it was, but was talking about the sort of the provenance tracking. We want to make sure we have a record of everything from basically cradle to grave. So from the initial designation of the object right the way through to it being exported into a paper or to the planetary data system, we want to keep a record of this in the database. So we have a record of all of our requests. We have a record of all the data frames we got. We have a record of all the photometric measurements we made from those frames. We have records of the products that we derived from this and whether we exported it and when we exported it. So one of the things that we might want to be using the TOM systems to do the follow-up with is this thing called AEON, which you heard a little bit about yesterday. So this is a collaboration of observatories for doing time domain astrophysics. And the idea is that observations can be programmatically requested. The observatories need to be queue scheduled at least some of the time, but we don't require fully robotic or fully queue. If you can contribute things at least some of the time, this is still very useful. And the other part of it is it's helpful if the observatories have a data archive, and it's helpful if they have a real-time or a rapid pipeline to give feedback more quickly, and you can close this loop from transient alert to characterization and subsequent follow-up more quickly. Currently, the AEON consists of the Las Cumbres Observatory Network, the SOAR 4-meter telescope, which Carrie will tell you more about shortly, and the Gemini observatories, which Brian will tell you about. So SOAR, we're currently supporting the Goodman imaging and spectroscopy instrument, and have recently added triple spec, which is a near infrared spectrograph. SOAR is moving towards more automated and supervised telescope operation. There are new data pipelines coming online for the instruments, and the amount of time that is being executed in AEON mode is increasing, and this is being run through LCO's scheduling system. SOAR is effectively treated as part of the LCO network for scheduling purposes. Gemini have a plugin for the TOM Toolkit that allows submission, and they've also recently developed one that allows you to query the Gemini archive. They're in the process of developing a new operating system for the telescopes, which has AEON in mind, and there are preliminary talks ongoing with Blanco. Aprigita yesterday mentioned the Rubin International In-Kind program. A lot of that is software, but some of it is also telescope time and facility access. And so several of these have been offered to the US Chilean community in return for data access rights. Compatibility was strongly encouraged as part of that call, and discussions and development are underway with things like the SALT 10 meter in South Africa and the Milankovic telescope in Serbia. As part of this, to get facilities up to speed, there was an observing facilities workshop that was held in Croatia as part of the LSST in Europe conference last September, which had participants from several observatories and provided hands-on training with the Open OCS and also the TOM Toolkit. And the content from this workshop is publicly available at this URL, and I'll post the slides so you can grab that URL later. So the observatory control system is a modular suite of APIs. So it's designed to provide modern observatory functionality in an open source manner that you could use to replace and control your telescope. So we have a submission portal. There is a configuration database that lists the details of the cameras and instruments and the telescope. There is a scheduler to schedule the telescope. There is a science data archive involved in this as well. And then a downtime database, which means the telescope isn't getting scheduled when it's not working. And the observatory control system is fully compatible with TOM Toolkit, so the TOM Toolkit can talk to the observatory control system. Finally, I just want to sort of return to this diagram and focus just on the sort of the top path, which is how alerts will flow from the surveys through to the science teams. There's a lot of independent research teams that hopefully want to share results and coordinate and collaborate. And they all have many different interfaces between the facilities that they're using, where they're getting their alerts from, and this is a real problem on how to share data. So one of the solutions that we are developing at LCO is this thing called Hermes. This is designed primarily for the gravitational wave multi-messenger follow-up. But myself, as part of the Solar System Science Collaboration of Rubin, we are looking at potentially using this for doing solar system alerts as well. And so the idea is that this is a generalized, both human and machine readable message communication format, which can replace the plain text things like GCNs or IU circulars. And that will allow alerts to come from the facilities and the brokers to things like the treasure map and to TOMS, and the results from that come back. So you can say, we searched the error box, we didn't find anything, we did find something, it has these properties. And so it's a very general messaging service that is designed to support any type of astronomical information. The messages get converted into this format called JSON, which looks very much like Python dictionaries if you've used those, and gets published through the Kafka-based hopscotch service. There is a graphical user interface which looks like this. So these are a bunch of LIGO Virgo gravitational wave triggers and some follow-ups. But there's also a programmable API as well, and this is an example composition of a Hermes message. So here we are saying that we followed up with ESO-VLT on this particular GRB. We took a spectrum of it. It has this flux. It covers this wavelength range, taken with force 2. So conclusions, LCO and its partners are developing several of these projects to help serve astronomers in this time domain ecosystem. So there is the TOM Toolkit, which lets teams manage targets and observations. We have AEON, which is a network of transient follow-up facilities. There is the Open OCS available, which is an open source observatory control system. And then there is Hermes, which is this modern messaging system for transient alerts. So the final sort of message I want to say is that, coordinating this large number of targets of interest that are going to come, or are coming out of the current surveys and will be coming in increasing numbers from Rubin, and the very small subset of those that can actually be followed, and all of the resulting observations and science products out of this will be a challenge. We're going to need new tools to do it. We have the tools to do that.
Thank you so much. Let's thank him then. Are there any questions? I see one over there.